Hello students, welcome back. We are in the second session of the very first topic in our 10th standard, chemical equations and reactions. Myself, Samjad Zakaria, Faculty of Chemistry, Global Education Center. So let's start with balancing the equations. So when you speak about a chemical equation, there are two types of chemical equation. One is balanced chemical equation and the second one is unbalanced chemical equation. So what is a chemical equation? How a reaction is happening? If you want to get in detail the basic introduction of chemical equations and reactions, please refer to the last session of this chapter. Yeah? Yes. Now, what is a balanced chemical equation and what is an unbalanced chemical equation? Why an unbalanced chemical equation need to be balanced? You know, the mass can neither be created nor be destroyed. So always the mass can neither be created nor be destroyed. That means whatever the mass of the reactants you get, once it is getting reacted, the same amount of products you need to get. That means mass of the reactants should be equal to the mass of the products, meaning to say total mass of the elements present in product should be equal to total mass of the elements present in the reactants. Once you get the both masses in reactants and products equal, you can call the law of conservation of mass is satisfied. So what is the need to balance an equation? An important question. Why balancing an equation, or what is the need to balance a chemical equation? The answer is in order to satisfy law of conservation of mass, so that total mass of the elements present in product should be equal to the total mass of the elements present in the reactants. Now getting in detail, now how to make the masses equal? In other words, we can call it as the total number of atoms of the reactants, the total number of each and every elements that is present in the reactant should be equal to the total number of atoms of each and every element that is present in the product. So in reactants you will have few elements, in the products you will have few elements. Now that element which is having certain number of atoms in the reactant should be equal to the same element which is present in the product. That means if there are 2 atoms of zinc in the reactant, there should be 2 atoms of zinc in the product. So in last session we had seen one example where zinc is reacting with sulfuric acid, giving you zinc sulfate and hydrogen gas. Zinc reacts with sulfuric acid to give you zinc sulfate and hydrogen gas. Now, in the process of balancing, the very first step is that identify the elements present in reactants as well as in the products. Now, zinc is the first element, hydrogen is the second element present, sulfur is the third, oxygen is the fourth. Now whatever the elements present in the reactant, the same elements will also be present in the product. Now in the product you have zinc, in the product you have hydrogen, in the product you have sulfur as well as oxygen. Now start to count the number of atoms of zinc. Here how many atoms of zinc is present? 1 atom. So zinc is 1. Here how many atoms of hydrogen is present? 2. Here how many atoms of sulfur are present? 1. How many atoms of oxygen? 4. In the product side, number of atoms of zinc 1, hydrogen again 2, sulfur 1 and oxygen 4. Now when you see the number of atoms of zinc in the reactant, is it equal to number of atoms of zinc present in the product? They are equal. Hydrogen atoms in the reactants, are they equal to atoms of hydrogen in the product? Equal. 2. Atoms of sulfur are also equal. atoms of oxygen are also equal 4. Now all the atoms, total number of atoms of each element in the reactant are equal to the total number of atoms of each element that is present in the product. Now in this case, law of conservation of mass is satisfied. This equation is already balanced. This equation is already balanced. Here when you add it up, you will get 8 number of atoms, as well as in the product also you will get 8 number of atoms. They are equal. Law of conservation of mass is satisfied. Now let's look on for the second example. Now in the second example, we are considering iron reacting with steam. Gaseous form of water is nothing but steam, giving you Fe3O4 plus H2 gas. Iron reacts with steam to give you Fe3O4 plus H2. Now this is a given chemical equation. This is a given chemical equation. We need to balance this equation. So how to balance it? First step, you have to identify the number of elements present in the reactant as well as in the product. So first element is iron, the second element present is hydrogen, the third element present is oxygen, and in the product side also there is iron, there is hydrogen, and there is oxygen. Now how many atoms of iron are present? 1. How many atoms of hydrogen are present? 2. How many atoms of oxygen is present? 1. How many atoms of iron in the reactant? Fe3. So how many atoms? 3 atoms of iron. Hydrogen H2. So 2 atoms of hydrogen. And oxygen, how many atoms of oxygen? There are 4 atoms of oxygen. Now when you see, are the atoms of iron equal in the reactant and product? No. Are the atoms of hydrogen also equal? No. Yes, it is equal. Oxygen, are they equal? No. Now this equation is unbalanced, where total number of atoms of reactant, most of the reactant element are not equal to the product element. Yeah, so you have to balance it. So the next step is, after identifying the elements and writing their total number of atoms in the reactant as well as in the product, the next step is identify the highest number of atoms. Identify the highest number of atoms. In here, which is having highest number of atom? Oxygen. That is how much? 4. Oxygen is having 4 atoms. So try to make oxygen in the reactant equal to that of atoms present in the product. So here there is 4. So what you have to do? You have to make this 1 as 4. You have to make that 1 as 4. Now when you make this as 4, oxygen, here also 4. So are the atoms becomes equal? That means you have to multiply that oxygen with number 4. When you multiply that oxygen atom with 4, now the atom in the reactant will be equal to the oxygen atom in the product. So when, and an important step you have to identify, or you have to realize that whatever is given in a given chemical equation, you cannot change or you cannot alter it. Meaning to say that this is highly militarized area. No, trespassing is not allowed. Not at all. See, I want to make this oxygen 4. Can I write somewhere inside the bracket 4 or below oxygen 4? No. You cannot change the subscripts of already present chemical formulas. Chemical formula subscripts cannot be changed while balancing the chemical equation. Always you have to remember it. Nothing can be changed. If an equation is given, that element or the formula in the process of balancing, you cannot change it. It's a big no. It's a big no. Now Fe plus H2O gives Fe3O4 plus H2. It should be as it is. Now when I write oxygen 4, now can I write H2O4? No, wrong. Now whatever the multiplied number you have to always put it as a coefficient. You have to always put it as a coefficient. That means in front of that element or compound which is written, element or molecule or a compound, whichever is written, you have to put that number as a coefficient. That means wherever I had put this double dash, it is a place where you have to put the multiplied number. Now oxygen you have multiplied by 4. Now this 4 need to be put in a place where oxygen is present. Where oxygen is present? Oxygen is present in H2O. Can I write H2O4? No, that 4 should be put before H2O, in front of H2O, meaning to say now that 4 will come over here. Now oxygen is balanced. Done. Now in the process of balancing, now hydrogen atoms are how much now? 4 into 2. Now hydrogen atoms changed. Now this 2 is becoming 4. Sorry, this 2 is becoming now 8. 4 into 2. The hydrogen is becoming 8. Now the highest number now is for hydrogen 8. So try to balance that highest number of atoms. Here hydrogen is 2. In the reactant side hydrogen is 8. So you have to multiply the product side by some number to get this 8. So this 2 should be multiplied by what number? 2 into 4 is 8. So you multiply by 4. Now 2 into 4 is 8. Here also 8. Here also 8. Now this 4 is multiplied for which atom? Hydrogen. Now where hydrogen is present? Hydrogen is present as H2. Now that 4 number, can you write H2 outside the bracket 4? No. It should be always put in front of H2. That 4 should be put in front of that multiplied number. Multiplied number should be put in front of H2. Now you will get 4H2. Now hydrogen is also 8. It is balanced. But when you see iron is 3 in the product side, atoms of iron are 3, but atoms of iron are 1 in the reactant side. So what you have to do? You have to multiply the reactant iron by 3. When you multiply by 3, 3 is equal to 3. Now this 3 is multiplied for iron atom. So this 3 should be put in front of iron 3. Now you see 3Fe, 3Fe, balanced. All the atoms are balanced. Now this is the balanced equation, 3Fe plus 4H2O giving you Fe3O4 plus 4H2. Is this equation looks balanced? Is this good? Yes. This is how you have to balance an equation. Now let's take another example, the second example of balancing. The second example we'll see Na, simple equation, plus O2 giving you Na2O. Na plus O2 is giving you Na2O. Now first step, identify the elements. Sodium, here oxygen, here also you have sodium, here also you have oxygen. Now how many atoms of sodium? 1. How many atoms of oxygen? 2. How many atoms of sodium? 2. How many atoms of oxygen? 1. Now you see, first go for oxygen. See, whenever something is present in a compound form, always go for that, so that balancing becomes easier. Give priority to Na2O because O is combined with sodium. O is getting combined with sodium, so give priority to this O. And now here O. See, here you have 2 atoms of oxygen, here you have 1 atom of oxygen, so you have to make it 2. What you have to do? Multiply by 2. Can I write Na2O2? No. All number should be put, the multiplied number should be put in front of the given compound or a given product. Now, in the process of balancing, now sodium had become how much? Now how much sodium had become? Sodium is 2 into 2, now it is becoming 4. But in the reactant side, sodium is 1. You should make it equal, so this sodium should be multiplied by 4. Now when I multiply by 4, this 4 should be put in front of Na. Now it is 4Na plus O2 giving you 2Na2O. This is the balanced chemical equation. So Let's move on with the next example, that is we are taking barium chloride. So how will you write barium chloride? Barium chloride is written as BaCl2. Hope everyone are thorough with writing your chemical formulas. So it is very important. Yes, barium chloride BaCl2 plus aluminium sulfate. How will you write aluminium sulfate? Al2SO4 thrice gives you, it's a double displacement reaction. We will be discussing it in the next session. Double displacement reaction. You will get a precipitate of barium sulfate BaSO4 plus aluminium chloride AlCl3. Now how to balance this equation? Here I will tell you a trick. In order to balance this, it is very simple what steps you need to carry on in this kind of equations. So first step is to identify the elements. You identify the elements. You have barium, you have chlorine, you have aluminium. Next, you see there is a sulfate, a polyatomic ion group of ions SO4 is there in the reactant side as well as it is there in the product side. So sulfate, a group of ions, you can take it as one entity. So SO4 you take it as together, SO4. Now here also you have barium, in the product side you have chlorine, you have aluminium as well as you have sulfate SO4. When you write this sulfate together, instead of doing for sulfur and oxygen separately, it might be time consuming. So it is better to take sulfate as one. It will be easier for you guys. So barium is one atom over here. Chlorine, how many atoms are present? 2. Aluminium again 2. Sulfate 3. Outside the bracket there are how many sulfates? 3. Now barium 1. See, chlorine 3. Aluminium 1. Sulfate again it is 1. SO4 1 polyatomic, that is one group of sulfate is present, SO4 1. Now here sulfate is 3, here sulfate is 1, so you have to make this sulfate into 3. So you have to multiply by 3, and always when you multiply by 3 you cannot put SO4 thrice. No, nothing can be done to the given formulas. Always it should be written as a coefficient. That means you have to write 3BaSO4. Now when you change this SO4 3, when you write it in front of barium sulfate, now barium is changing into 3. Now here barium is 3, but here you see what happens. Barium should, here also the barium should be 3. So you have to multiply by 3 and put 3 in front of barium chloride. Now chlorine becomes 6, 3 into 2, chlorine becomes 6. Now here chlorine is 3, in order to make it 6 you have to multiply by 2. Now that multiplied number you have to put it as a coefficient in front of aluminium chloride, because chlorine is present with aluminium, combined with aluminium. Now you have to put 2 in front of aluminium chloride. Now aluminium is automatically it is becoming 2. So total number of atoms, barium is 3, barium 3, chlorine 6, product side 6. In the reactant aluminium is 2, same as product. Sulfate 3 group of sulfate ions, here also you have sulfate 3. Now this equation is balanced. So whenever a large group of polyatomic ions are present in the reactant as well as in the product, take it as one entity and try to balance it. The balancing becomes very simple. Yes, in the next session we will be moving on to types of chemical equations. Till we see, bye. Thank you.